Hello everyone, and welcome to our latest series of Fireside Chat, where we talk about how companies are collaborating, closing the gap towards net zero sustainable future. My name is Heikki Vepsäläinen, Division President for Large Motors and Generators at ABB. I'm very happy to have a guest today, Guy Nicholson, Head of Grid Integration at Statkraft in the UK. Guy, most welcome.
Thank you, Heikki. And it's nice to be here.
And today we talk about decarbonization, renewable energy transition, which is actually the vital and foundation towards the sustainable future. But that also comes with certain challenges. Challenges like grid instability. So I'm very inspired to hear Guy's insights on the topic. So Guy, let's get started. Can you tell us briefly about the Statkraft and your role in the company?
Yeah, well, Statkraft is probably best known for its Norwegian hydropower. And as a result of that and our other activities, we're the largest renewable energy generator in Europe. But the area of business I'm focused on is the development of new projects, particularly renewables, and how we actually integrate those renewables into the grid. So my role is developing what we call our greener grid parks. And our greener grid parks are there to provide service to the grid to enable all this cheap, wonderful, fantastic wind and solar power and hydropower to integrate into the grids cost effectively and seamlessly and safely and stably and with the benefit to the environment and consumers alike. So yeah, that's the big picture, if you like.
Excellent, Guy. So once again at COP28, end of last year, held in Dubai, we heard that how critical climate change is. This means lots of changes on industrial companies to cut the emissions.
Yeah.
So no company is able to do this on their own. They need to collaborate. And companies also need to have a direction and common objectives, missions, where to go. And I really like actually how Statkraft is formalizing the slogan, renew the way the world is powered. Can you a little bit elaborate what energy transition means to you, Guy?
Yeah, it's a massive topic and it affects us all, it affects everything. And I think in a nutshell, it's about, electricity is the key to this, isn't it? So the way we can decarbonize our society is by using electricity for more and more stuff. So first of all, we've got to decarbonize electricity supply, and that plays to the renewables, very much what Statkraft's talking about, renew the way the world is powered, by getting renewables into electricity. Then we are also getting electricity to replace transport, electric vehicles versus fossil fuel vehicles, heat pumps versus gas boilers, industry, and even those hard to abate sectors, that people talk about like steel, cement, and some of those industrial processes. So I think from Statkraft's point of view, we're in over 20 countries with about 6,000 people. And our mission is really to grow that renewable electricity supply to enable, companies like ABB to roll out that kind of delivery of that electricity into the market to decarbonize activities. So that's kind of how I see it. And, my role in that specifically is making sure that as we push the amount of renewables in the grid harder and higher, we can keep that grid stable, operating, safe and low cost. And I think, there's been a lot of historic talk that, you've got variable renewables, and people use this horrible term intermittent, which I hate. It was coined by the fossil fuel industry to get at renewables. Renewables are variable, yes, and that's a challenge, but it's getting all that renewables to customers and having a reliable grid is what we're about.
So Statkraft is really in the heart of driving the change on energy transition. Energy transition is cutting CO2 emissions, but that also comes with certain challenges. When more renewable is connected into the grid stability needs to be addressed. So it needs to be adopted also differently on transmission and distribution, which is really on the core to keeping the lights on. So can you, Guy, a little bit elaborate what is actually the challenge and what Statkraft is doing to address the topic?
Yeah, so I think people talk about the challenge in lots of different ways. People talk about flexibility, stability, and the key to me in stability is the big change for renewables is the fact they're connected with power electronics. So traditional generators, coal, gas, nuclear, hydro, all connected with synchronous machines, nice, stable, big lumps of metal spinning round and keeping that frequency on the grid to a large degree. With power electronics, they don't have that spinning mass, so they don't have that inertia. And that's been one of the key things, which is, where our project ListaDrive comes in, which ABB supplied the machines for, and the flywheels, that is providing inertia to the grid. So that's one key difference. I think, there are others in terms of those renewables are generally in different locations to the conventional plants. So we've got to have more transmission and assets to move the power around. We've got to have more facts, if you like, to variable transmission assets to manage those power flows. So that all plays into the changes that we need to make to accommodate the renewables. And then you've got the fact that we've got that variability in renewables. Sometimes we have lots of surplus power, which is cheap, and therefore storing that in energy storage, initially batteries, pump storage, hydro. These are both technologies that Statkraft are involved with, potentially longer term in hydrogen, storing hydrogen, again, something that Statkraft's involved with. So these storage technologies working with the variable renewables, working a lot with demand side management. So, making sure that the demand can respond to the prices in the market, respond to the amount of renewables available. So when we've got lots of renewables, power's cheap, can you bring in that power? Can you store it? Can you use it when it's cheap? When it's expensive, because we've got low renewables, can you, cut back on use? Can you shift your load and do those kind of things? So it's a kind of systems problem in a way, and all these different parts and players, bits all working together. So it's not like there's kind of one big central solution to this. It's everybody plays their role in this in all sorts of different ways.
Yeah, so it's more like a decentralized power grids, which actually you mentioned. One of the core solutions is greener grid parks, where Statkraft and ABB has been collaborated. Like you mentioned, the ListaDrive, where ABB has provided synchronous condensers, which is the fastest way to adopt the grid volatilities.
Yeah.
And also to drive into reliability and availability to keep the lights on. Can you share your experience about the ListaDrive project so far?
Yeah, well, we've been operating for just over about a year now, and very good in terms of reliability and uptime. It's performing well. And, just for as an example, 22nd December in GB, we had quite 3 major events on the grid in short succession. We lost an interconnector to France, so about a gigawatt of in-feed into the GB system, which is, round about, at that time, about 30 gigawatts. The frequency dropped. ListaDrive was part of that process, providing inertia, slowing that frequency decline down. We saw a lot of batteries responding to that frequency. So again, new technology that wasn't around 10 years ago on the grid at all, was able to respond to that. We then had a conventional gas station, which tripped as a result of this change. It wasn't supposed to, but it did. So we had another frequency drop, and then we had an HVDC link, what we call a bootstrap on the grid trip, and that caused a big disturbance and tripped off some other generation. So we had 3 events, and the project ListaDrive responded to that by providing inertia into the system. So as the frequency slows down, the synchronous machine, the flywheel, feed energy back into the grid and slow that frequency decline, giving time for frequency response like batteries to push more power in to make up for the fact that we've had these three big losses. So in the old days, without this kind of technology, you could say, well, would the lights have gone out in that situation? That's obviously something that everybody avoids. But what we're trying to do here is provide the technologies that prevent the lights going out in the most cost-effective way. And before ListaDrive came along, National Grid, the system operator in Great Britain, would have to run additional gas-fired power stations. So we had a situation back in lockdown, back in 2020, COVID times, I remember, where we had low power demand on the grid because of all the shutdowns. And we had quite a lot of renewables around, as it happened, wind and solar. And that was kind of like moving the power system forward 10 years suddenly because of the reduced demand due to COVID. So National Grid suddenly found they were having to intervene in the market. The market said, we don't need any fossil fuels. We've got a bit of nuclear, we've got some hydro, we've got some biomass, and we've got lots of wind and solar. There's no need for us to run any fossil fuels. So the market said, no gas, no coal will run. But the system operator went, hang on a minute, the grid's going to fall over. We don't have enough inertia, we don't have enough voltage control, don't have enough frequency response. So we can't allow that to happen. So they then have to intervene in the market. And one afternoon, they put on 17 gas-fired power stations, not because they needed the energy from those power stations, but because they needed the inertia, the voltage control, the reactive power. And so turn off a lot of wind, turn on a lot of gas. It's very expensive. It's bad news for carbon emissions. So, that was a real wake-up call. This is what is going to happen on the grid more and more in the future if we don't do something about it. And so the likes of ListaDrive, Stability Pathfinder, we deliver a service to National Grid, providing inertia, providing short-circuit current, providing stability. System strength is a term we like to use, actually, increasingly. So that enables all that wind and solar to still produce without having to be switched off to make way for horrible fossil fuel power station. So, yeah, it's a great, ListaDrive is a great example of how things are changing.
So ListaDrive is really serving the purpose, like you mentioned, increasing the grid stability, the rigidness of the system, but at the same time reducing also CO2 emissions because the gas turbines don't need to run in idle period or idle mode. Excellent.
Yeah, and we estimated that our two Stability Phase 1 Pathfinder projects, ListaDrive and Keith, saving about 0.5% of GB electricity emissions, which was quite a surprising number when I did it. I thought that's pretty good for two projects.
Yeah.
And 0.5% is not much, but in the overall scheme of the grid, it's a significant number.
Hey, it's a significant number, and it's also starting point for something more greener in the future.
Yeah.
That's also how we built the foundation, but let's a little bit look this more holistically when we talk about the net zero sustainable future. There's 3 areas to be addressed, which you kind of touched already. What the companies are doing to help their customers to reduce the CO2 emissions, could be energy efficiency. What do we do with our suppliers, and what do we do on our own operations? Like large motors, we have reduced our own operation CO2 emissions by 80% with the 2019 baseline. That is actually a big number. So we have invested solar parks on the factory rooftops, recovery heat from heating systems, regenerating electricity back into the grid from all the testing fields we have. So quite a big investments, but also we want to walk the talk. So Guy, can you a little bit explain what the Statkraft is doing to reduce the own CO2 emissions on your own operations?
Yeah, our business is generally generating electricity, but as you say, with our green grid parks, we're providing the system services or ancillary services, you might call them, to run the grid. We're also doing things like electric vehicles. We have MER, our EV charging business, which is providing electric vehicle charging. So we're also kind of widening our scope beyond just generating electricity to managing it and helping users to use those end services. So, and I think, when I started and I've worked in renewables all my career. When I started, you were a complete fruitcake. People used to laugh. Oh, wind, solar, because it was, expensive. It was very novel technology. Didn't work very well. But the fact that we've developed those technologies and put in the R&D, put in the support schemes, have brought them down. Now they are the most cost-effective. And solar, particularly, is growing massively globally and is going to be a massive impact on global electricity production. And the key thing is that we embrace that wind, solar, water, battery storage approach to decarbonising electricity. That will bring down the cost quickly. People talk about need for carbon capture storage, biofuel and energy and carbon capture, nuclear. I think there's all complete red herrings. The future is wind, water, solar, storage, batteries, and that will be the cheapest way of decarbonising and the fastest way. And we need to do it fast because, all the time we're putting carbon dioxide into the atmosphere or methane or other greenhouse gases. We're shortening that lifetime of getting to 1.5 or 2 degrees. And energy efficiency is a great way of doing that because you're saving everything back up the supply chain, and then renewables, the new renewable technologies, getting those rolled out quickly, and that's what we're about at Statkraft.
Yeah, you're touching an interesting topic because 45% of the world electricity is consumed by electric motors. And there is 300 million electric motors, industrial motors, running out there. Only addressing this portion, we would be able to meet that 1.5 degrees by energy efficiencies. And this goes back on this, no companies alone is able to do this. So collaboration is needed across the companies like Statkraft and ABB on ListaDrive. Can you elaborate examples what Statkraft is doing on the field of collaboration or partnering?
Yeah, well, ListaDrive is a great example, isn't it? We don't make synchronous machines, we don't make flywheels, but we develop the projects, and you guys at ABB came in and delivered the key equipment to make that project work. And we also went out to other parts of the supply chain to build the rest of the project. It's a multi-vendor, multi-supplier kind of process. And I think there's also, as well as collaboration, there's also competition, which is good because it helps drive prices down. It helps you innovate, helps you think outside the box, helps efficiency. And I'd like to kind of give a shout out to National Grid as the electricity system operator in GB, who has put out the Stability Pathfinder competition. So they went, hey, we need inertia, let's have a tender for it, let's go out to the market. And people came forward with all sorts of different solutions, running pump storage hydros as sync comps, converting old gas power stations to sync comps, and like ourselves coming in with new technology like from ABB at ListaDrive with synchronous machines with flywheels. So great, that engenders the competition, it engenders the innovation, it engenders the collaboration. And as a result of this, we've been talking about the challenge of inertia and integrating renewables and what happened in COVID. National Grid have got a target now to operate the GB electricity system, England, Scotland and Wales, which is a synchronous system. Operate that system with zero fossil fuel electricity in 2025. Doesn't mean for the whole year. It means for maybe an hour when we have the right amount of wind and solar, a bit of hydro, maybe a bit of biomass and nuclear sitting in the mix. But to operate that system with no fossil, no gas running. There's very little coal left on the system anyway. So that's virtually gone. So big change there. So yeah, I think they deserve a shout out for that, and that'll be a great milestone. And maybe we and ABB can, Statkraft and ABB can celebrate that occasion, because ListaDrive will play a key part in that particular event.
It's already a success as it's having high reliability, availability, providing the lights on for the consumers in UK.
Exactly.
Thank you, Guy, for the inspiring discussions and fascinating comments you brought us today. Road in front of us is challenging. No company is able to do this alone. Companies need to collaborate, building the bridge towards net zero sustainable future. Companies like Statkraft and ABB and many others need to partner. What we need is leadership, determination, and everyone's contribution, because this is possible together. Thank you for watching.